Okay, so I am discussing complemented subspace problem, and this problem has some solutions in the research paper of J. Lindstrass and T. Jaffrey. So these two guys published a paper in 1970, I think. Yeah, 1970 in Israeli Journal of Mathematics. And this is the famous mathematician. He is the failed medalist of 2010. And his father was also a great mathematician, mother was a computer scientist. And his sister is also a mathematician, so he is from rich background of mathematics. So let me address the problem of complementary subspaces. So what do you mean by a complement subspace? Complemented subspace. So this is the first question. Okay, so in case of Banach spaces, a closed subspace is called complemented if there exists another closed subspace whose intersection with earlier one is 0, and we can express our whole space as a sum of these two spaces. Okay, then we say that a closed subspace is complemented. So let me write down the definition of complemented subspace. So let X be a Banach space. A closed subspace E is said to be complemented if there is another closed subspace say F such that first thing A intersection F is equal to 0, and second thing is you can express your X as a sum of these two subspaces E and F. Then you will say that E is a complement, E is complemented subspace. F is called the complement. Okay, so this is the definition of a complementary subspace. So now the question is, does always every Banach space has complemented subspace? Okay, I'm going to mention the name. F is known as complementary subspace. Tensor space. Okay, in case of Hilbert space, we have a projection on the Hilbert space. So for every closed subspace, there always exists another closed subspace that is a part of that subspace, a orthogonal complement of that space, which is also closed subspace, and you can express your whole Hilbert space as the direct sum of these two, those two spaces, closed subspaces. So in case of Hilbert space, every closed subspace is complemented. So this is the remark in case of Hilbert space. In Hilbert spaces, every closed subspace is complemented. Okay, but we knew this result that not every Banach space is Hilbert space. Of course, every Hilbert space is a Banach space, but it is not necessary that every Banach space is Hilbert space. So we cannot quote this result. that every Banach space, in every Banach space, every closed subspace is complemented. So there are plenty of Banach spaces and plenty of closed subspaces in those Banach spaces which are not actually complemented. But it is a difficult problem to characterize or to find out those closed subspaces actually which are complemented in Banach spaces and those which are not complemented. So that is problem open to everyone. You choose different Banach spaces and characterize those complemented subspaces and those are not complemented subspaces. So this is the different thing. But what Z. Lindstrass and T. Jaffari done in this paper of 1970 will be discussed today. Okay, I am only for these two guys. Few results also known in Banach spaces, and what are those results? The first result is every finite dimensional closed subspace. Okay, when I am saying finite dimensional, it is automatically closed. Finite dimensional subspace is closed. Okay, it is not a big issue to prove this result. But the main result is every finite dimensional subspace of a Banach space is always complemented. The second result is in Banach space, every finite dimension subspace is complemented. And one can find the proof of these results that I am putting here on internet. So it is not very difficult. I am giving hint to prove this result. We will use one can use Banach theorem to prove this result. So Banach theorem is the essential part while proving this result. And another result is this. So let E be a closed subspace of Banach space X, a codimension of E, that is dimension of X quotient space X by E is finite, then E is complemented. Again, proof of this theorem uses the Banach theorem and functional calculus also, not Banach algebra, C-star algebra, function calculus, only functionals are required. Okay, so using Banach theorem, one can prove these two results and they are not difficult. So while rubbing these results, I want to move the main results that these two guys have done. So what they did? So their theorem is this. Till now what we have said? Only here what we did. The first thing, in Banach space, a closed subspace is called complemented. If you have another closed subspace such that you can express your whole space as sum of these two spaces, then you will see one of the space as complemented subspace and another as a complementary subspace. Okay. And second, in case of Hilbert space, every closed subspace is complemented due to the orthogonal projection. You always get perf of that space, and that perf will be the closed. Okay. And the third result is, in case of Banach spaces, if you have finite dimensional subspace, then that subspace is automatically complemented, not automatically using Banach theorem. And the fourth result was, if you have a closed subspace of any Banach space, and if the codimension of that subspace is finite, means dimension of quotient space is finite, then the subspace will be complemented. Okay, so if your Banach space is itself finite dimensional, then from these results that I told verbally, that every subspace will be complemented. Why? If your Banach space is finite dimensional, if X is a finite dimensional Banach space, if your space is finite dimensional Banach space, then I am saying every subspace of X is complemented. I am not telling about closed subspace because it is finite dimensional. Every subspace is finite dimensional, and when every finite dimensional subspace is closed, so automatically it is a closed subspace. So every finite dimensional subspace of X is also complemented because X is finite dimensional. Okay. So what if X is not finite dimensional? So then these two guys came into the picture. So let X be a infinite dimensional Banach space. Let X be an infinite dimensional Banach space, then it is not necessary that first, it is not necessary that X is Hilbert space. It is not necessary that every closed subspace of that infinite dimensional Banach space is complemented. What happened if every closed subspace of this infinite dimensional Banach space is complemented? The resulting portion is proved by these two guys. What I am saying, if you have an infinite dimensional Banach space and further every closed subspace is complemented, I am not saying few complemented closed subspaces. Every closed subspace of is complemented. So I am imposing this condition. If every closed subspace of X is complemented, then very important thing, X is isomorphic to some Hilbert space, to Hilbert space. This is the big conclusion of this theorem. It means if X is an infinite dimensional Banach space and every closed subspace is complemented, then its null is always can be introduced by inner product structure, some inner product structure. Okay? So very important. And these two guys proved this result using propositions. So I will discuss those propositions in my next video. So this is the base what we want to do. We want to prove this theorem. Okay. So another problem is, are there infinite dimensional Banach spaces where there are always some closed subspaces which are not complemented? The answer is yes, provided that your space is not isomorphic to some element space, or the your norm is not arises from some inner product. Because if your norm is arises from some inner product, then that Banach space is a Hilbert space, and in Hilbert space every closed subspace is complemented. Okay, so the question. So this is the very famous problem. There are Banach spaces of course infinite dimensional, in which there exists closed subspace which is not complemented, And what is the example for in support of this? An example is very trivial. Take L infinity sequence of all bounded sequences. So L infinity denotes the set of all bounded sequences. Bounded sequences, and it is a Banach space under subnorm, say infinity norm, and C0 is sitting inside L infinity as a closed subspace of it. So C0 is a closed subspace of L infinity, and C0 is nothing but is the collection of all null sequences. Collection of all null sequences. Null sequences means those sequences which are converging to 0. And it is, and this problem, and the problem that Phillips has proved that C0 is the closed subspace of L infinity, which is not complemented. Phillips was a mathematician. Phillips is a mathematician, not us, who has proved that Phillips has proved C0 is not complemented. And someday I will give a proof of it. I will prove that result. Complemented. So there are plenty of examples of Banach spaces in infinite dimensions which has closed subspaces actually which are not complemented, and there are lots of closed subspaces which are complemented. So one question is arising in my mind. Can you tell me some Banach spaces whose dimension is infinite, which has no non-trivial closed complemented subspace? Means, see, 0 and x. You pick any Hilbert, any Banach space. These two are the always complemented spaces. Closed subspace, complemented. But do we have non-trivial closed subspace? Non-trivial means A not equal to 0, also not, and this is the proper subset of x. So do we have proper non-empty subspace of x which is closed, also complemented? Yeah. Are there some examples of Banach spaces which has no non-trivial closed complemented subspaces? Okay, so it is my task to gather these things in this coming week and the next week, because I want to utilize these concepts in my research papers that I have done on composition operators on little L spaces. So I have found few results on composition operators where I can utilize these results. Just I have started reading these articles within 1 or 2 days. So it is a new but interesting. So I am closing my video here.